Okay. Alright, so today we're going to work with polynomial functions. Two of the three things that we're going to do today are concepts that we've already covered. So hopefully they won't give you too much trouble. The first thing is factoring. Now we all factored in chapter 4. We all factored quadratic expressions. So this is really not much different. The only difference is instead of a quadratic function or quadratic expression, we have in this case what? What do we call that? A polynomial. Yes, but so is a quadratic expression. If I had to give this a name, if the question was classify this polynomial, what's the degree? The degree is 3, which makes this a... No, trinomial is the number of terms. Lucas? Cubic. Remember, the first name refers to the highest degree. It's x to the third power. That makes it a cubic. This has 3 terms, makes it a zirconia. So a cubic zirconia. Cubic trinomial. Cubic trinomial. Ladies, be careful. Don't let your man buy you a cubic zirconia for an engagement ring. Because it's fake. Anyway, so let's see if Lucas. No, not you. Okay, Lucas. Do you know? Who said that? Okay. Do you know why Simone is so mean?
Yeah.
Okay. Okay, Simone, now I'm going to ask you the question instead. Do you know what the first step is that we have to do here? How?
You take the x cubed and then negative 2x squared.
No. Can we do that? Are those like terms?
No.
No. One's a third power, one's a second power. But simplifies a very good start.
What else?
What?
The number 2,
No. What do we know, Jillian?
You have to put them in the correct form.
When you say correct form, what do you mean?
Like you have to for factored it's in it you have to put like the I.
all the same.
No. What does anybody notice about each of these terms? What do they all have in common? They all have an x. What do we look for? And the answer to which is they all have an x. We're looking for what?
Put them together.
Similar
Like
areas.
Not like terms. That's really combining like terms. I don't want to use the wrong terminology.
Something to factor out.
Factor.
Out.
Something to factor out. When we look to factor out, what are we looking for?
Oh, the GCF.
Similar.
We're looking for the GCF. Excellent. Jillian.
I told you before, but I couldn't bring it.
Well, I apologize. We're looking for the greatest common factor, or GCF. And as was pointed out, the greatest common factor here is x. So that's the first thing that we're going to do. We're going to factor out the greatest common factor, which in this particular problem is just x. What was that?
Since he said something, you should ask him.
That's right. Turnabout is fair play. Okay. Lucas? Lucas?
Yeah.
Tell me something you notice about this trinomial. The x is gone. Yes, good. You notice anything else?
Oh, the two
I'm
X.
asking. Hold on. I know he can, but I want you to try. Well, Pete, you have powers of observation. What do you notice?
She's gone.
Well,
The little one. No,
the
the-
2 is gone.
Whatever you want to call it. Okay.
The exponent?
Yes.
Well, you should know it. You should know that this is called an exponent. Yes, the exponent from here is gone, makes it 2x. Alex, what do you know?
Oh, the X. No.
What about it?
It was an X3.
Okay, so let's, if this was a court of law, I don't know any of you in the law academy, have you discussed what a stipulation is?
What
Okay,
you're saying
a
is-
stipulation is something that is conceded by the other side, so that you don't have to fight about it. Excuse me. So I will stipulate that we factored out the x, and when we had x squared, now we have just x. Where we have x cubed, now we have x squared. I want to know what else you noticed, Jillian.
Well, because of the distribution property, you would take one x away from each one. So now, they're in parentheses, and then you can distribute it, and then that's how you have it.
If I distribute this, what am I going to get? What happens if I distribute this x back into the trinomial?
If there is
I get back to what I started with. So that's not going to help us. Okay, this is a trinomial. What's the a value of this trinomial? 1. Does anyone remember how to factor a trinomial with an a value of 1? A quadratic trinomial at that. We did it in chapter 4. Wasn't that long ago. We even had a little rhyming phrase to help us. We want the factors. We want the factors of c that add up to b. Very good, Rachel. When the a value is 1, the factors of c that add up to b. Josue, what are the factors of negative 15 that add up to negative 2? Which is the positive, which is the negative?
Positive is divided
So you want x
Oh,
plus
wait.
5.
I was so wrong.
So wrong.
LOL.
What do you want?
I want the positive to be 3 and the negative to be a 5.
You want this?
I want that.
Anybody disagree? Alex, do you disagree with Josue?
Like last time?
No.
No, you want the same thing?
Yeah. You don't want to ask me what?
No. Good, because that's correct. That's the answer, by the way. Okay, now, if you are a good math student, what you're going to do is check your work. And the way you check your work is you go backwards. That's right. First, you're going to FOIL the two binomials, and then you're going to distribute the x. So again, you FOIL the two binomials, and then you distribute the x back into the equation, or the expression, I should say. And hopefully you get the same thing that you started with. Yes, sir?
Is the answer the one with the X on the left?
No.
Parentheses or without the X? That, okay.
That's the answer.
Thank you.
This is the check. What's below it? This is the answer. Okay, does anybody have any questions? Okay, let's go over this, please. Oh, the one person I want to call on is went to the rest. So instead, we're going to call on Yeka. Okay, Yeka, can you please share with the class the first step in solving this, or factoring this, I should say. Excellent. And what is the greatest common factor of those three terms? X. So what did you get after you factored out the X? Oh man, that's great. Thank you, Yanka. Good job. Crystal, can you pick up the ball and run with it, please? What's the next step? Multiples of 12? Factors. Very different factors and multiples. Okay, what are the factors of negative 12 that add up to negative 1? So, x minus 4, x plus 3, is that your answer? Is that your final answer? You want to phone a friend?
That's what me and George got.
Well, there you go. Gerard, did you get the same answer or a different answer? You got the same answer. Excellent. Did anybody get a different answer? You did?
No, I'm asking if you can use 1 and 2 slowly.
But 1 and 2 are factors of 12.
Right.
So you could.
Not.
No.
So you need the factors of negative 12. 1 and 12, 2 and 6, 3 and 4. Okay. Any questions? All right. The next thing we're going to do is really easy.
Yay.
What?
Is it easier than this? This is pretty hard.
Can I check it? Ha, ha, ha.
You won't win.
Oh, Ennis isn't here today. Jillian, can you check this, please?
Yes. So, first you have to boil it.
Boil it. So we're going to multiply the two binomials together. So what do you get?
2x.
You get what?
I mean, x is 3.
X times X.
What? Wait, what?
X times X is
2x.
X squared.
Okay, and then you would do outside,
Oh, excuse me. Go ahead.
and then your outside would give you negative 12. Or no?
Outside. Then we do outside. What are the outside terms here? X and 3. So we multiply them together. We get 3x. Inside terms, negative 4 and x are negative 4x. And then the last terms, negative 4 and 3 is negative 12. Combine my like terms, 3 and negative 4. I get x squared minus x minus 12. And now I'm going to distribute. So x times x squared is x to the third. X times negative x is negative x squared. Negative 12 times x is negative 12x. Thank you for asking. Check. Nice to see one person who checks their work.
Get it. Here, not mine. All right, I got you.
Okay. The next thing is easy. Okay. Okay. The next concept is called finding the zeros. Okay. Does anybody know what that means? What does it mean to find the zeros? When I talk about finding a zero, thank you, Lou. In mathematics, what does it mean? What? What's right? Oh, I thought you said something. Anybody? Bueller? No? Okay, finding the zeros means what are the values of x? If I made this an equation, see, it is an equation. See my equation? My equation, finding the zero means what are the value or values of x that will make that equation equal to 0. In other words, I'm asking you to solve this. It's no longer a quadratic, it's now a polynomial. We're solving this polynomial. Now ordinarily, you'd be given this long polynomial, you'd have to solve it by factoring and solving like we did on the previous page. But we're skipping right to here are the three factors. We want to know what the zeros are. So we talked about two different ways to do that. Does anyone remember either one of the ways? One of them is the short way, one of them is the longer way. It wasn't that long ago.
Can we do the short way?
We are going to do the short way. I just was wondering if anybody knew. Okay, so the two ways are take each binomial factor and set it equal to 0 and solve for x. The easier way is whatever the values are inside the parentheses, the x value that makes it 0, in other words, the 0 is the
Opposite.
opposite. Good. So if my factor is x plus 2, what's the value that's going to make this binomial equal to 0? Negative 2. So x is equal to negative 2. X is also equal to 1. And x is also equal to 3. And that's all that you need to do for this.
Really?
Well, that's all that I'm going to do with you about this. In the book then goes on and graphs this.
Yeah, that's not.
But my experience is that it takes too long
Yeah.
to explain it, and then I can't test well on it, so I'd rather skip it. However, we are using it for something else. But before we go on, does anybody have any questions about how to do this? Okay. All right.
Great trials.
No. Don't need to try that.
So how we get to that?
No. Part of it. Anyway, okay, now, notice what we have here. I'm telling you what the zeros are. And what we're going to do is we're going to build a polynomial. So we're actually going to do the opposite of what we just did. What we just did is I gave you the polynomial, or at least I gave you the factored form of the polynomial, and you had to come up with those zeros. Now I'm giving you the zeros, and we're going to build a polynomial. And in fact, we're going to build a cubic polynomial. So that should automatically tell you what your first term should be. X to the third power. That's right. Okay, so if I have a binomial and my 0 is the opposite of what's inside the binomial, if I'm given the answer, what does my factor look like? So if I have negative 2, what's the factor? What's the binomial that goes with negative 2? X plus 2. And what's the binomial that goes with positive 2? X minus 2, and then this one is x minus 3. So that is actually step number 1. Write a linear factor for each 0. Linear factor, also a binomial. In other words, you take the opposite of the zeros. You make the 3 little binomials. Just want to point out, 1 week from Friday is your first test for the 3rd quarter. Just pointing that out.
What is that?
A week from Friday, the 24th. Plenty of time.
I won't worry about it.
Good. Don't worry about it. Don't worry about it at all. Just be prepared. You don't have to worry. Okay, so the next step is we're going to start combining these binomials. So what you're going to do is you're going to take 2 of them and call me in the morning. No. You're going to take 2 binomials and multiply them. So I took x minus 2 and x minus 3. You may take any of the 2 pairs and multiply them together. Either way, what you should get is, in this case, a binomial and a trinomial. Bless you. I want to point out that you're not always going to get a trinomial. In fact, we're not going to have time to do it. don't get a binomial and a trinomial, you get two binomials. So don't automatically assume that your answer is here is always going to be a binomial and a trinomial. It might not be. It really just depends on what the factors are. As a matter of fact, if I multiplied x plus 2 and x minus 2 together, I would get a binomial. Does anybody see? Does anybody see? If this is my answer, anybody recognize this from chapter 4?
Yeah, they cancel.
No, they don't cancel out. But what? Kind of, sort of, yeah. But if I were to multiply these two together, I would get x squared minus 4. Because this is the difference of two squares. If I factor the difference of two squares, what do I get? I get square root of the first term, square root of the second term, 1 plus 1 minus. So if I had chosen these two terms, I would then have a binomial and a binomial, which you can then FOIL to get your answer. So it's actually an easier way to do it than the way the book shows you. But we get a binomial and a trinomial.
How'd you get x to the second minus 5x plus 6? Or how'd you get x plus 2?
X plus 2 is this.
How'd you get that?
Okay, so you
This,
just bring it down.
this is when I FOIL these two things. When I FOIL x minus 2 and x minus 3. I get x squared minus 3x minus 2x and then plus 6.
So you're switching sides.
No, I'm FOILing these.
Well, like when you're putting never mind.
X times x is x squared.
Well, yeah.
X times negative 3 is negative 3x.
Yeah.
Negative 2 times x is negative 2x. And then negative 2 times negative 3 is positive 6.
No, I meant like the beginning, like step, like negative 2 is to positive 2.
Yes.
That's, yeah.
Take the opposite.
Yeah.
So here I have negative 3x and negative 2x combined to make negative 5x.
Well, you just said multiply x plus 3. Oh, wait.
You're going to take these two factors and FOIL them.
Oh, okay. Oh, wait, okay. Good. Yes, you go.
Okay. So,
So you can take any two factors.
that's right.
Okay. You just have to choose this two.
That's right. In fact, I wish I had looked at this more closely because I would have chosen those two.
Yeah.
Anyway, unfortunately, if you end up with a binomial and a trinomial like we have here, the only way to go to the next step is to double distribute. Take each of the numbers inside the binomial and distribute it against the trinomial. So I'm going to do x times x squared minus 5x plus 6 and 2 times x squared minus 5x plus 6. And then what I do is I take my answer and I just write it out in a long string of values. Okay, so everybody should be able to tell me what the last step is. Simplify by doing what? Combining like terms. So I'm going to combine all my like terms. I get and my answer. Please make sure that your answer is in standard form, from highest exponent to constants. Okay, does anybody have any questions?